Hi, welcome to Educator.com. Today we're going to be talking about variability. All right, so we're going to start off with just a conceptual introduction to the different kinds of ways that you could measure variability. Then we're going to talk about range, quartiles, and interquartile range. Then we're going to talk about variance and standard deviation. And in particular, we're going to focus a little bit, on the concept of sum of squares. Then we're going to talk about population standard deviation versus sample standard deviation and talk about the differences in their formulas. And then we're going to calculate standard deviation in Excel. All right, let's get started. So let's think about a conceptual way of thinking about variability. There's lots of different ways that you could actually think about variability. So for instance, let me give you this example. Let's say this X right here, right? Let's say this X shown in each of these is the president. Right now, Barack Obama. And so let's say that this is the president. And these are different groups of people that are standing with him at some sort of formal party, right? Formal event. So here we see the Secret Service, and this is how far each of them are from him. Here we see the Supreme Court justices, and they're sort of scattered around him, spread out around him. Here are his cabinet members that he's appointed, and so they're sort of scattered around him. And here are the Tea Party senators. And let's just say maybe that there are senators that don't really like the president as much, right? And so they're sort of seem to be huddled over here, right? Now, which of these groups of people is sort of most spread out from the president, right? Which of these groups of people is sort of closest in, right? Who's closest to the president? Can we describe that with a number, right? Well, there's a couple of ways you might want to think about it. Well, one way might be, just look at the farthest person away from the president in each of these sets, right? So maybe for this, it's either this guy or this guy, right? And get that distance, and maybe that's the distance you need. So for this, maybe it's this guy, or maybe it's this guy, right? Maybe here it's that guy over there, right? Maybe here it's this guy, or maybe that guy. They seem pretty distant, right? Maybe that guy's a little bit farther, right? So just looking at the farthest person in the group, right? That's one way of looking at it. In that case, it doesn't really matter how many people in the group you have, right? So this group has fewer people than this group, but it wouldn't matter if we're just looking at just the one farthest guy in the group, right? That's one way of looking at it. Another way of looking at it is maybe creating a little boundary and saying, how many people are in that boundary, right? So maybe we have this little square around the president, and we just look at how many people are in that square. So maybe for here, if we draw, oops, sorry, my square's sort of crappy, but if we draw a square like that, how many people fall in that square, right? If that was our measure, we would say, oh, this group is the closest to the president, right? Here we have like one person in the square, and none of the other groups have any people in the square, right? And then maybe we could look at different types of squares and see if that changes anything, right? So that might be one way of doing it. Another way of doing it might be to sort of maybe find the area of the border, right? Right? Maybe that's another way of doing it, right? Maybe this one. And that one doesn't seem like a very good model, because that would mean that these people are the closest to the president. But this is sort of an odd group. They're close to each other, but not necessarily close to the president, right? Should that matter in a measure of variability? That's another thing to think about. But probably one that probably comes to your mind is sort of this idea of maybe the average distance of all these guys away from the president, right? So who has the closest sort of average distance, right? Then we also wouldn't need to worry about how many people are in the group because we divide by the number of people in the group, right? And it actually wouldn't matter if they're close to each other or not, right? We just care about distance sort of to the president, right? And so those are sort of different ways that you could think about variability. And so notice that they're all ways of sort of sticking a number on this concept of variability, but you might come up with different numbers, and you might come up with different sort of definitions for what it means to be spread out versus very close, right?